Hello, my posse. If you watched the last module, you might be thinking, wait, that's it? That's what AI is? And honestly, fair reaction. Rule-based systems are like training wheels of artificial intelligence. Important, foundational, but not exactly thrilling. But don't worry, we're just getting started. In this module, we're laying the groundwork for something much more powerful, the theory behind machine learning. So let's get started. In order to understand how machine learning works, we must first compare it to traditional programming. In traditional programming, we give the computer a set of instructions, a program that we have coded, and some input data. The computer then follows those instructions exactly to produce an output. For example, if we write a function that multiplies two numbers, we're essentially defining the logic, the program. When we call that function with inputs like 5 and 6, our data, the computer runs the code we wrote and returns the output, 30. The key idea is that the logic comes from us. The computer just follows instructions. In machine learning, the traditional approach is flipped. Instead of writing a program to process data, we give the computer data and optionally the desired outputs, and it figures out the underlying rules or patterns, effectively generating the program itself. The idea here is that if we were to give the computer new data and the generated program, it can produce accurate outputs. Yes, even for data it hasn't seen before. So here's a concrete example of how machine learning works. Let's say we were given the following task: identify if an image contains a butterfly. What we would essentially do is feed hundreds of images to the computer, both positive examples, that is, images of butterflies, and negative examples, images of something other than butterflies, maybe of other animals, flowers, etc., to our computer. This is our data. We can also call it our domain. If the dataset is incredibly large, say millions of images, we could even call it big data. Besides the data, we also feed the computer the output, or as we like to call it in machine learning, a label. The label in this case can be +1 or -1. +1 if it's a positive example, yes, it is a butterfly, or -1 if it's a negative example, no, it's not a butterfly. Obviously, this is +1. This is -1 because whoever this is, too good looking to be a butterfly. And this is +1. By the way, in case you were wondering, you could have also chosen the labels as +1 or 0. Depending on the model you're using, one labeling might be preferable over the other. Okay, so we feed in our data and our labels and voila! The computer spits out our program, or as we say in machine learning, our model. Spitting out is a bit of an exaggeration. Really, what's going on is a step we call training the model. It can take anywhere between a few seconds to several days to train the model. Okay, so now if we were to provide the computer our trained model along with an unseen image, basically an image that was not in our original data set, that would serve as an input to our model, we would hopefully be obtaining an accurate prediction. +1, this is a butterfly. Now, remember when I said outputs or labels were optional to provide to the computer in machine learning? Well, that's because whether or not you need labels depends on what you're trying to solve. Without going too much into depth right this minute, I want to introduce the 4 categories of machine learning. The first category is supervised learning. If we think of supervised learning as baking a cake, don't judge me, I'm sure you like cakes too. The ingredients are your data or your domain and your labels or output. The cake itself is the generated model. Our butterfly image classification example is a classic case of supervised learning. The second category is unsupervised learning. The only ingredients to our cake is the data. There are no labels provided. A good use case of unsupervised learning is authorship attribution for texts with disputed authorship. In this case, we train a model on a collection of texts without providing the names of the authors. Those labels are intentionally withheld. The model groups texts based on stylistic or structural similarities, forming clusters that reflect underlying patterns. Once those clusters are formed, we can compare the disputed text to them and infer likely authorship by examining which group it most closely resembles. The key point is that labels are applied after the fact, not during training. The third category is semi-supervised learning. It's similar to supervised learning, but not all data is labeled. A vast majority of the labels are missing. A great example of semi-supervised learning is recommendation systems. To suggest relevant products to a user, the system ideally needs to understand how the user felt about items they've purchased, whether they loved them, disliked them, or felt neutral. That feedback, often in the form of ratings or reviews, serves as our labels. However, most products on a platform haven't been purchased by every user, and even when they have, many go unrated. That means we're working with a mix, a small set of labeled data, products with ratings, and a much larger pool of unlabeled data, products with no feedback. Lucky for you, you don't need to create a recommendation system to figure out what I like. My tastes are exquisite. If you felt you were in the mood to gift me silken hair bows and organic catnip, I wouldn't stop you. Anyway, the fourth and final category is reinforcement learning. This category is a bit different from the other ones. Environment states, potential actions, and environment rewards are all ingredients to our cake. Reinforcement learning is a powerful tool in gameplay. Trust me, when I've hit my limit with endless chess matches during babysitting duty, Charlie's relentless. I let a reinforcement learning bot take over. It plays just well enough to outmatch him, and once Charlie's had enough, he usually shifts to something else. Thank goodness. Wow. Okay, I guess all this cake chatter has my stomach rumbling. I think that's my cue to wrap things up and bake myself a cake. In the upcoming videos, we'll dive deep into datasets, what they are, and how we can sharpen our ML superpowers by leveraging them. See you next time. Hey you! Yes you! Interested in MehtA's AI and machine learning certification program? Register online for this paid program to access homework, sample questions, and eligibility quiz to receive certificates. Students 18 and younger can earn titles such as AI Explorer, AI Scholar, and AI Fellow. And adults can be invited to be AI experts. We also offer one-on-one AI mentorships for students and professionals. And free MehtA AI Lab resources for any K-12 and undergrad students wanting to launch their own AI club. Full details on our website. Don't procrastinate!
MehtA AI+, that's my zone. Leaping hurdles, breaking boundaries, never alone. Miss pause on the block.